Let's continue. Number 7b. Limit x approaches to 0 of sine of 1 over x. So you know from your previous math class that sine, for example, sine t is t, right? How does the graph go? It is like this, where this is 0, this is pi, and that is 2 pi, minus pi, and maximum 1, minimum minus 1, right? So from 0 to 2 pi, I have one curve, and then it repeats itself. So the period is 2 pi. Every 2 pi interval, it repeats itself. That's sine t, but if we have sine 2t, then the period becomes pi. So within pi interval, I have one curve. So it will go like this. Oops. Like this, right? And continue. So on and so forth. If it is sine 3t, let's see which. If it is sine of 3t, then I get more faster frequency. It goes like this. Suppose it is increasing to, for example, 100t. Then it will be like this. Very rapid oscillation. Rapid oscillations. Right. So, for example, if we have sine of 1 over x as x approaches to 0, as x approaches to 0, 1 over x approaches to infinity, plus or minus infinity. If x is bigger than 0, then it is minus infinity. If x is less than 0. So here, if I have sine of minus t, then it is, from your trick, you know that this is minus sine t, right? So my usual graph will get reversed. It will be like this, opposite of what we had for sine t. And if I increase this to minus 100t, then I will see a rapid oscillations here as well. So as x approaches to 0, 1 over x goes to plus or minus infinity. So if I look at the graph of sine of 1 over x, as x approaches to 0, then it will be like this. So near 0, this is very, very big, plus or minus infinity, and I will see this infinite frequency, infinitely many frequencies. So the graph does not approach a single number. There is, it oscillates between 1 and minus 1. 1 and minus 1. So it does not approach. A single number. So in such case, we say limit does not exist. It does not approach a single number. So the limit does not exist. Yeah. Okay. Next, C, limit x approaches to 0 of 1 over x squared. So as x approaches to 0, x squared is always positive because we know that x is never 0. So 1 over x squared approaches to positive infinity. It gets bigger and bigger and bigger, right? So this is not a number. It's an expression. It is not a number. It does not approach a single number. Infinity is an expression that it is getting bigger and bigger. It is not a certain number on a real line, right? So it does not approach a single number. Therefore, we can say limit does not exist. Later in class number 4, we will talk about limit as it goes to infinity. But for now, it does not exist because it does not approach a single number. And then next example, D, limit x approaches to 0 of square root of x. Okay, so if we look at the graph, x, square root of x, square root is only defined, as you know, right, for non-negative numbers. At 2, it is approximately 1.414, etc., right? So, but the limit x approaches to 0, meaning we are approaching 0 from the left and from the right. So on the left, it is not in the domain. It is not in the domain of f. Therefore, as it is, problem does make sense. Limit does not exist. Because to say something exists, we must have something on the left-hand side to determine the limit. But for this case, the function does not exist. The function itself does not exist on the left of f. So as it is, the limit does not exist. Okay, that's important. How can you make this into a correct statement? The correct thing is the following. The true statement is the following. This is true. The true statement is limit, yeah, we have to put 0 plus, right, square root of x. Then I can say this is 0 because from the right of 0, the graph goes to 0. So this is true, but as it is, the answer is limit does not exist. Okay, so that's important. Okay, limit laws. So we'll use these laws when we determine limits. Okay, so limit law is very important. We will abbreviate this as LL. Limit of k as x approaches to c. Note that we have limit x approaches to c f of x. So that k is function k. It is f of x equals to k. So for example, if we have x approaches to c of 5, that 5 is not on this real line. It's not this 5. It is not this. That 5 is a function 5. So domain x, this is f of x, is the function f of x equal to 5. So it is this constant line. It is not a number on a real line. Okay, it's a function f of x equal to 5. So no matter where my c is, as x approaches to c, it approaches to 5. So limit of constant function as x approaches to c is that constant. So remember this fact. Okay. And then limit x approaches to x. Again, that x is f of x equals to x. That's a function. This is a position for function, right? So if we draw that function x, f of x, since x equals to x, the graph goes like this. So at any c, its function value is also c. So this is c. Okay. And then limit x approaches to c of square root of x. So since it is x approaching c, not x approaching c plus, right? So c should be, as we have seen in the previous problem, the graph goes like this. This is x. So c cannot be here because we cannot approach c from the left. And c cannot be 0 because we cannot approach 0 from the left. So to approach c from both sides, from the left and from the right, c should be a positive number. So to make sense with this problem, c should be positive. Under that condition, what is the limit of square root of x? Well, as x approaches to c, from the left and right, the graph approaches this number, which is square root of c. So answer to this is square root of c, assuming that c is positive. These little things are important. Okay. So here, for c positive. For c positive. Okay. And then D. If limit of f of x as x approaches to c is L, and limit x approaches to c, g of x is m, whether L and m, it means they exist. So these are numbers. L and m are definite numbers. When do we say limit is L? When f approaches to a single number, right? So L and m are numbers. Those are definite existing numbers. We can say finite numbers. They are not like infinity or minus infinity, okay? When they are finite numbers. Then we can say the following. 1. Limit of a constant multiple of a function is the constant multiple of the limit of the function. So limit of constant multiple, let's say alpha times f, where alpha is constant. Alpha is constant. As x approaches to c, as x approaches to c, is equal, right? Is the constant multiple alpha of the limit. So alpha of the limit of the function. That's what it means. So if we have alpha multiplied to the function, we can take that alpha outside of the limit. This is called constant multiple rule. All these are important. 2. Limit of a sum is the sum of the limits. Limit of a sum is the sum of the limits. So limit of the sum fx plus gx, x approaches to c, is the sum of the limits. Sum of the limits. X approaches to c fx plus x approaches to c gx. Sum of the limits. Okay, this is called sum rule. What about difference? Suppose I have minus there, then it can be viewed as f of x plus minus 1 times g of x. Limit of this. Then by the sum rule, it is limit x approaches to c f of x plus limit x approaches to c of minus 1 times g of x. Limit of the sum is sum of the limits. And then this is constant, so it can be pulled outside. And it can be written as limit x approaches to c, x approaches to c f of x minus limit x approaches to c g of x. Yep. So we can say limit of difference is difference of the limits. So if we have f of x minus gx, it is limit f minus limit g. Make sure that we can do this when the limits are finite definite numbers, when L and M are definite numbers. So we cannot say if limit x approaches to c, f of x is, for example, infinity, and limit x approaches to c, g of x is infinity, you cannot say infinity minus infinity. You cannot apply this law in such cases because infinities are not definite numbers. So all these rules does not apply in those cases. Okay, 2. 3. Limit of a product is the product of the limits. Limit of a product is the product of the limits. Product means multiplication. So this is limit x approaches to c of the product fx times g of x is limit x approaches to c f of x product of the limits. Okay, multiplication of the each individual limits. Yeah, that's product rule. And then quotient rule 4. Limit of a quotient. Quotient meaning a ratio, fraction. Limit of a quotient is the quotient of the limits if the denominator is not 0. So, limit of the quotient, limit of a quotient, limit of a fraction equal to fraction, quotient, right? Quotient of the limits f of x over limit x approaches to c g of x. This is called quotient rule in the limits. Okay, if the denominator is not 0, so we have to make sure that the denominator's limit is not 0. So for example, if I have limit x approaches to 3 sine x over x minus 3, can we say this is equal to quotient of limit of sine over limit of x minus 3. Is this right? No, that's wrong. Why is this wrong? We cannot apply limit law because the denominators, as x approaches to 3, x minus 3 will go to 0. So doing this way is very, very wrong. That's incorrect. Okay? So we have to make sure that the denominator is not 0. Okay, so why are they true? All of the above can be proven using epsilon delta definition of the limit. So that was, if you remember, given an error, desired error, given an epsilon positive, we were able to find there exists delta positive such that I can make my actual output and ideal input less than epsilon whenever that means such that whenever if I make my input close by delta bigger than 0, because we never can have ideal input. Yeah, so with this we can show all the limit laws. Those proofs are done in higher level math, not in calculus. So here we will just assume that these are all true without proof. Okay. So for example, a limit of x squared. So this is limit x approaches to c x times x. I can think of this as f of x and think of that as g of x. And we know that limit x approaches to c, x is c. Right? And c is a definite number. These are definite number. Finite number. Definite number. Therefore, by limit law, limit of the product is product of the limits. Product of the limits. Limit of the product is product of the limits by limit law. So this is c, right? That's c, and this is again c. So the answer is c squared. Okay. Limit x approaches to c to the x to the n. That n is a natural number. 1, 2, 3, 4, etc. Okay, that n. So this is a power function. By what we just did, by limit law, limit of the product is product of the limits. So this is same thing as having this n times. For example, if n is 2, then it is this. If n is 3, then there will be one more, etc., etc., right? So it is that thing to the n, so that will be c to the n. Okay. B, limit x approaches to c 3 times x squared. We see that 3 is constant alpha, so it can be pulled out. So again, by limit law, it is 3 times limit x approaches to c x squared. We know that it has a finite number as its limit. C squared is finite number, definite number. Therefore, this is 3c squared. Okay, so if we have limit an times x to the n, that is just a constant. Constant. Then again, I can pull this outside of the limit by limit law. So it is by limit law, an times limit x approaches to c, x to the n. So it is an limit, again by limit law, x approaches to c, x whole quantity raised to power n. So it is an c to the n is its limit. So c, if we have such a thing, so this is called polynomial. So we have constants, and then the powers are 0, x to the 0, x to the 1, x squared, etc., x to the n. Such a thing is called a polynomial. For example, f of x equal to x cubed plus 1 is a polynomial because it can be written as 1 plus 0x squared 1x cubed, right? So this is a polynomial. Whereas f of x equals to x to the 1/3 plus 1 is not a polynomial because 1/3 is not natural number. Not a natural number. It is not a natural number. Natural numbers are 1, 2, 3, etc. These are natural numbers. But 1/3 is a fraction. It's a rational number, not natural number, right? So it is not a polynomial. Anyway, if we have a polynomial, then since limit of each of these have finite limits, limit of the sum is sum of the limits, and then I can take this constant outside. So limit of a polynomial is this. It is a0. Okay, so it is by limit law, limit of the sum is sum of the limits. So a0 plus limit x approaches to c, a1x plus limit x approaches to c, an x to the n. And from part A, limit x approaches to c of constant k was k, right? So it is a0, and for this we take that out, we take constants out and take the limit, so we get a0 plus a1c plus an c to the n. That's the limit. So here's what we get. Suppose I call this function as p of x. Okay, then this is nothing but p evaluated as c. So for a polynomial, we have this limit x approaches to c. Polynomial p of x is p of c. For polynomials, we can do direct substitution to find the limit. Direct substitution. We can just plug in c into the x to find its limit. For polynomials, direct substitution can be done. Okay, limit of p and q are polynomials. So This is a polynomial and that is a polynomial. For example, limit x approaches to c, square root of 2 times x cubed minus 1 over square root of x plus 3. It is not of this because of this thing, right? That's x to the half. So it is not like this. The correct example would be square root of 2x cubed minus 1 over x plus 3, for example. Then this is px over q of x. So that's a sub n. A sub n can be any real number, but the power should be a natural number. So that powers are important. Okay. So yes, this is of this form. And such a function, polynomial over another polynomial, is called a rational number. Rational function, sorry. Polynomial over polynomial. Poly over poly is called a rational function. So limit of a rational function by limit law. I'm out of space, so let me write it over here at the bottom. Okay, so limit x approaches to c, px over q of x. By limit law, limit x approaches to c, p of x over limit x approaches to c, q of x. If this is not 0, then we can do that by quotient rule in the limit law. Well, so this is equal to, since this is poly and this is also polynomial, we can do direct substitution for the polynomials. So it will be p of c over q of c, knowing that q of c is not 0. If q of c is not 0, then we can do direct substitution, direct substitution to find the limit if q of c is not 0. If q of c is not 0, then we can do direct substitution. So for example, to find the limit of this, if c is not minus 3, right? Then we can say its limit, we can say this is equal to square root of 2 times c cubed minus 1 over c plus 3, if c is not minus 3. Okay.